We've switched the order a little bit, so up next we've got Jeremy Clowes, who is a water resources engineer with Urban Systems in Kelowna. Jeremy's been employed by Urban Systems for the past 5 years and has worked extensively on municipal water and sanitary projects. Jeremy was the design engineer for the Alberta Central East Water Transfer Station, which is his topic for discussion today. His interesting fact is that he's very passionate about water. Only once has his passion momentarily faded, which happened to coincide with a mid-December swim in Lake Superior.
Thanks everyone for being here. I will be discussing the newly constructed Alberta Central East Regional Water System, which is located east of Edmonton. The first phase, which has been constructed, will service 4 municipalities, including Lavoy, Willingdon, Two Hills, and Harry Hill. Last year, 83 kilometers of pipeline, a 2,300 cubic meter reservoir, pump station with 850 horse pumping power, and a chloramine boosting system were constructed under Phase 1. This year, an additional 83 kilometers of water main will be constructed under Phase 2, works out to a total of 166 kilometers of water main being installed and $77 million being invested over a 2-year period. My intent for today is to provide you with some background on the creation of the ACE regional system, provide you with an overview of the system and how it will function, and review some of the challenges that we encountered. The communities that ACE will service have been dealing with poor groundwater supplies, both in terms of quantity and quality. The ACE Water Corporation demonstrates that a regional system can be a viable option for providing smaller municipalities with a safe, reliable, and affordable water supply. When the well is dry, we know the worth of water. This quote by Benjamin Franklin is very well suited for our discussion today. So let's get into the background on the ACE Water Corporation. It all started with the county of Vermilion River. The area in and around the county has experienced serious drought conditions over the past 2 decades. In 2004, the county identified the need to secure a sustainable water supply, and the North Saskatchewan River was identified as the most sustainable source. Various municipalities joined the county in a regional system initiative. In 2009, a preferred concept for a regional system was selected. Source for the proposed system is the Capital Region of Vegreville Corridor Water Services Commission. This is another regional system that is near the CVR. Try to put that name to memory. In total, there was an 8-year review and consultation period. At the end of this period, 13 member municipalities formed the ACE Water Corporation. Alberta government provided 90% capital funding for constructing the preferred concept. Summary of design and construction timeline: 2010, design is completed. 2011, project is tendered and construction begins. 2012, Phase 1 commissioning to occur next month, and Phase 2 is under construction. So let's move on to the system overview. ACE Water Supply is chloraminated and originates from EPCOR, owner and operator of Edmonton's water system. All of ACE's users are supplied by the ACE Water Transfer Station. This is the reservoir and pump station I mentioned earlier. Transfer station is equipped with 4 200 horse and 2 25 horse vertical turbine pumps and a surge control system consisting of 5 4.5 cubic meter tanks. Total Phase 1 service population is just under 2,000. The current max day demand is 20 liters per second. We are not talking about large demands or huge communities here. Phase 2 will extend service to the communities of Brantford, Innisfree, Manville, and Vermilion. Future phases will include an additional 174 kilometers of pipeline, 2 additional booster stations. The system is designed to meet a 25-year max day demand of 197 liters per second, or 17 megaliters per day. This includes allowances for rural and industrial demands. ACE will supply water to its users at a rate no higher than their respective 2035 MDD. The system is not designed to provide fire flows or peak demands. The pumps can operate in a flow or head control state. Flow control is our preferred operating method as it uses the least amount of energy and provides the lowest operating costs, as pumps only increase the system pressure enough to meet actual demand. Head control state is only used in the event that SCADA communication is lost between the water transfer station and service municipalities. ACE can boost chloramine levels as water is pumped from the water transfer station. Process utilizes an online analyzer to detect free ammonia and total chlorine in the influent water as a basis for establishing how much chlorine and ammonia to add. Adding the right amount of chlorine and ammonia is crucial. We want to be at or left of the peak on this curve. This is where the best chloramine is formed, which is monochloramine. Adding too much chlorine will cause dichloramines or trichloramines to form, which lead to taste and odor issues. Not adding enough chlorine could lead to nitrification. We will review a few different challenges that we encountered over the next few slides, water quality being the first. Water being supplied to ACE can be up to 3 weeks old. It can age an additional 50 days in the ACE system and have a total age of 71 days. Lab testing showed that we needed to boost chloramine levels, no surprise, but it may only be required during summer months, and we only needed to boost at the water transfer station. This is the Watt Lake crossing. We directionally drilled 700 meters of 300 mil fusible PVC pipe under the lake. According to the pipe manufacturer, it is currently the largest fusible PVC installation in Canada. 300,000 pound drilling rig was used to install this pipe. Designing the system to operate in a flow control state created a bit of a challenge for some of our equipment suppliers due to large pressure fluctuations that are expected. Working pressures can be anywhere from 20 to 230 psi. One equipment example would be our Singer control valves we used. A dual chamber body was required to ensure the valve would open on low inlet pressures. In closing, the ACE Water Corporation was created to provide reliable drinking water supply to rural communities. ACE system will supply high-quality treated water from the North Saskatchewan River to its member municipalities, and the ACE system has presented a few unique challenges that we were able to overcome, such as maintaining water quality with increased water age. Regional water systems can be a practical and economical solution for providing a sustainable supply of drinking water to smaller municipalities. Thank you.